It's a real pleasure to introduce Professor Judy Kay to you, which I'll be doing. Mentioning that her presentation is sponsored by the newsletter as well as government and the Union for Trade and Investment, and we thank them for helping us with that. Judy is a professor of computer science at the University of Sydney, and she leads the CHI research group. What does it stand exactly for again, Judy? Computer Human Adapted Interaction. And there'll be a slide of that in the end, but the acronym is never revealed. Now, just a couple of bits of pieces on Judy and what she's up to. She's been busy for most of her professional career on topics that relate very much to things the learning sciences and education technology research is concerning itself with. I guess it's probably fair to say, and I just picked a piece of her very busy homepage, but at the same time very informative homepage. Just to give you an idea about her sort of current activities and editorial roles. This is just one color of her homepage. And just to highlight, among other things, she's just been stopping to be president of the International Society for AI in Education, which traditionally had a lot of relations to people from here. She is on the editorial board since a long time of user modeling, user adapted interaction, which is probably one of the longest running journals that deals with personalization in a very deep way. Active in a number of other boards that are of relevance also to our enterprise. One of her themes, and the one I guess she'll talk a little bit about, but I don't quite know, is has to do with privacy and managing, I guess, particularly relevant these days, managing the potential, the positive potential that information in the cloud and in web tools and in increasing digital environment offers us. But at the same time, and for a long time also have been aware and thinking hard about the risks, in particular the risk for the individual, for the end user, who becomes now increasingly transparent, because as we know, for instance, these companies here and the services they offer, they all keep, and increasingly so, keep tracking you and us, each of us, and they start also, I guess, in the background combining their information, or their additional services that combine the information. And while this has many advantages, in particular for personalized information displays, for personalized and targeted support to find what one is looking for, it also has risks. It's in particular risky because, by and large, the end user is not in control of his or her information. Often we don't even know that we are traced. We have no real opportunity to scrutinize the validity of the information that's gathered about us. We cannot even explicitly at this stage query the model that these devices build of us. And we cannot check for correctness or change it or decide with whom we want to share that model and with whom not. And so, if you look at Judy's work since really 20 years, she's thought very hard and very creatively about how to, as I said, come up with ways where we can capitalize on the potential and at the same time, avoid the imminent risks. And her take on it is scrutable user models, as in to scrutinize user models that the end user can control, and more than that, he can also change them, or she can change them and decide what is visible to whom, for how long, etc. So the notion of a scrutable user model or scrutable open learner model is a continuing The second theme is life-wide technologies, or like not only lifelong learning, as is relevant for personalized learning and for privacy, but also life-wide technologies, so devices and technologies that permeate our physical environment. Very interesting research, and again, starting much earlier than many commercial products available now on surface technologies, such as in particular tabletops. If you want to know more, visit her homepage. In addition to her introductory keynote now, visit her homepage. It has links to all these things, and also to the CHAI group, which is in particular concerning itself with surface technologies. So please join me in welcoming Judy.
Fighting the technology. Well, thank you for the kind words. Hope I can live up to them. I actually duplicated some of my background in this introductory slide. The fact that I've been involved in the AI Ed Society and that I've chaired its conferences and the ITS Society. So AI Ed, Artificial Intelligence in Education, and Intelligent Tutoring Systems, two sister conferences and societies, are really the tech end of the same stuff that you guys do here. And the other thing that I've been doing is pervasive computing. And whilst many of you are friends from AI Ed and ITS, I don't actually recognise anyone here who's been to pervasive, but please come up and tell me if I missed you. The thing that I really share with all of the people here is a real concern and commitment to improving teaching and learning and education. And in my case, to build technology to help do that, to tackle problems that we currently can't address without improving technology. So, here's an overview of the talk. And before I go into it, I actually was going to talk about scrutability and lifelong user models. Thank you, Peter, for introducing that. But I decided it was too techo. So it's in the slides at the end that I'm not talking about, but I will happily take a question. What I am going to talk about is my current passion of Sisyphean tasks and lifelong learning. So this is our overview. Novel user interfaces. Electronic footprints, which is getting very close to this issue of personal data. Long-term curriculum design and management for places like universities. And so let's get started. I have a personal example here, and this is actually partly a public service announcement for all of you who are slouched with poor posture over your email. So suppose I want to improve my posture, something that nearly everyone who uses computers should probably do. So how do I go about this? Here's my goal. And I want a computer system that helps me do that. So it should, this is a teaching system at some level, should tell me when I'm doing things wrongly. For example, when I'm slouching. A personal one-to-one tutor would do that, or a mother, or father. It should tell me when I'm being too inactive, because that's part of it. It should help me find stuff that I've seen before about posture. You know, all the things you read and you need them now. And new things, and it should inspire me to do these things. And now we get to the metacognition. It should help me make a plan and get good at planning, because we know that most of us could be better than we are. And to remember to do things I plan to do and monitor my performance and then revise my plans. And maybe be meta-meta and learn how good I am at doing those things and learn to be better at doing them, or at least knowing how good I am. And then a very important dimension is who I would share that information with, parts of my learner model, stuff that I collect about me, maybe with health professionals, a buddy, or maybe a community of people called the posture improvers or something like that, something we can follow up. And obviously there's a lot more. And I see that as the sort of long-term learning that I would like to tackle at this stage. And I call this a Sisyphean task. So now, it's early in the morning, and you've just had breakfast. So I want to introduce you to a technique that I use. I do personalisation. I build computer systems that personalise, and I like to personalise things to my audience. So I need to learn a bit about you. So let me tell you the technique. Listen carefully, please. because everybody's going to have to participate, or I will point at you and embarrass you. So I'm going to ask you a question, and if the answer is yes, you put up your right hand. Well, that's my right hand, but of course it's the opposite side for you. If the answer is no, you put up your left hand. And if you don't understand the question, or you're confused, or you just can't make the decision, put up both hands. So the deal is everybody in the room should have at least one hand up, and just at this point I'll tell you this is good for your posture and good for your health. So a bonus. So the question I want to ask, so I get a sense of my audience, is please indicate, right hand yes, if you know, you've heard of the notion of Sisyphus. Left hand if you haven't. Okay, we've got a lot of right hands, thank you very much, everyone did very well, excellent. So here is a picture of Sisyphus, and the people who put their right hand up, I'm going to disabuse you of what you probably thought Sisyphus was about, and the people with their left hand, I will introduce you to the true path. So here's Sisyphus, and he is a bloke from a Greek myth. And I want to emphasise that the Greeks had this notion of mythos as in contrast to logos. And mythos is meant to be about metaphors for helping us develop a vocabulary so we can talk and think about things that are important. And this is important. So Sisyphus was this character. He actually challenged the gods, and his punishment was that for eternity he had to push a rock up a hill. And as you can see here, it's a big rock. He had to work alone. And every day, at the end of the day, it rolled down just as he got near the top, and the next day he had to do it again. Now, the people who put their right hand up when I asked them if they'd heard about Sisyphus probably think of it as a way of describing the task that's futile. You know, if something's really not worth doing and it's, I mean, pushing a rock up a hill is hardly worth doing, right? It's often that if you're doing something that's tedious, hard work but not worth doing, you describe it as Sisyphean. But I would like to take a slightly different view, and Albert Camus had a very different view. He saw it very much as a metaphor for life in his very existentialist way. And he said, at the very end, that the struggle itself is enough to fill a man's heart. One must imagine Sisyphus happy at the end of each day. And so, I want to redefine Sisyphean tasks for the people who had their right hand up and define it for the people with their left hand. They're done repeatedly, over and over, to achieve important lifelong goals. And here's a link back to posture. You've got to worry about your posture all the time. It's not something you do for a week and then it's done. It's a lifelong concern. And the real frustration is that there doesn't seem to be any apparent progress on a lot of these tasks. You can't make any serious progress in a day. However, could it be that Sisyphus just had trouble detecting his progress? I mean, hey, look at the muscles on that guy, if you can see it. And if you pushed a rock like that up a hill, you'd have some serious muscles. And so this is very much in line with what Peter introduced, the personal informatics movement, know thyself, who say if we have a lot of data which we can collect with all these wonderful new devices, we can measure stuff about ourselves and we can measure progress on Sisyphean tasks. Let's do the hand thing. Who's heard of the personal informatics movement? Right hand up if you have, left if you haven't. Okay, mainly, well, I'm surprised, there are quite a few rights. Okay, excellent. And I expect this one's even more popular, the quantified self. Who's heard of that? Right hand up if you have, left if you haven't. Oh, even less. Okay. So both of those are about collecting data so you can track stuff you want to know about yourself. And I'm at the moment talking about Sisyphean tasks, but now I want to link it to the stuff that everybody else in this conference is talking about, because I didn't notice any papers about improving posture. Come and tell me if I missed that one in the program. So here's another class of Sisyphean task. I want to learn some skill, X, to the 10,000 hour skill level. So how many people have heard of the 10,000 hours? Right hand up, left hand if not. Okay, so we've got a lot of right hands, but quite a few left. So there's work that was done initially in conjunction with working out what it takes to be a world-class violinist. And they concluded that to be a world-class violinist, you have to work really hard. Really, really hard. You have to have first-rate teachers, but you have to do 10,000 hours of purposeful practice. Okay, maybe 10,000 hours. We don't all aspire to achieving that, have our students in every class become world-class. So let's be 5,000 hour level competent. That's still pretty good. And let's let X be learning to program, because the whole world should learn to program. As a computer scientist, I'm not biased. So now what do I want a teaching system or a set of teaching systems to help me with? And that might include people. Well, firstly, tell me when I'm doing things wrong. There's no way you'll become a first-rate programmer if someone doesn't critique what you do. So if I write spaghetti code, someone should tell me that. Or if I'm being slow in clocking up those purposeful practice hours, because I need to do that, or if I'm not pacing myself right. Help me find things, information about programming well, new things that I can do and be inspired to do them. Again, the metacognition that I had before. If you're concentrating, it'll all look familiar. And to share my model, the information about me, so that I can learn better. Whoops, I've got health professionals there. I duplicated the slide a little too closely. Also to find a buddy who I can work with, and a community of programmers. Okay, all of these are sorts of things that that teaching systems can help, or bits of software can help with. So, I want to now take a few more examples of really long-term tasks. Suppose you want to learn a foreign language. You have to practice. And this is a graph that's taken from the Quantified Self website. And it's showing the rate at which you forget. So this leftmost blue line shows the rate at which you'd forget something if you've only reminded yourself once. But then if you remind yourself again a little bit later on, you hold the memory for a bit longer, and so on. And if you really want to learn stuff, you've got to practice it several times, and it's got to be spaced. Now that's hard to remember to do. Even in a learning, in a formal class where people have tried to set things up, it's challenging to do. But this is something software could be terrific for. But of course this applies for lots of other things you need to practice. Chemistry, maths. You know, I did maths at high school. I don't remember a thing. Maybe, you know, 5 years on it had told me that a little bit of refresher and I could keep all that in my head. Maybe. But how do we get there? How do we get to make progress on these long-term learning tasks? And it is a challenging and long journey, and I'm going to pull in this character, and I'm going to ask you, put your right hand up if you recognise this little character, and your left hand if you don't. Okay, thank you, that's good. Well, quite a lot of people do. It's The Little Prince, and Saint-Exupéry wrote a book which is really for parents to read to children. I'm not sure what the children get out of it because it's really pitched at parents. But anyway, the Little Prince visits a bunch of planets, and at each planet he meets one idea that's described very briefly. So that's what I'm going to do in my talk. I'm going to visit little visits to a number of projects that our group has done towards these long-term learning tasks. And there's a paper here I've cited that has quite a lot more detail and quite a lot more technical detail as well. So one thing that I think is going to be very important is new ways to interact. And Trent Atted and Anthony Collins did the lion's share of the work on what I'm going to show you now. So in about 2005, the first interactive tables that were commercially available came out, and we got one. And to put it bluntly, there was no software. And we sat down and we thought, well, you know, there's going to be a lot of this stuff in the future. We need really good software for the hardware that's going to be available in the future. And new hardware is coming out all the time, and it's getting cheaper and cheaper. It's still pretty expensive. It still isn't the things we'd really like it to be, but we decided to build a framework for creating applications on tabletops and on walls, interactive surfaces, that would be able to work nicely on the hardware that would evolve over time. And thanks to the superb expertise of my wonderful PhD students, we have got a superb framework. And when we get a new piece of hardware, we normally have it working within a day, and it works really nicely, whether it's single touch like the whiteboards that are in many schools, or multi-touch like the fancier things you'll see in these videos. So here we have a video of how we think that these should fit into our interaction. We have three people here. Bob, who's just coming in with his tablet computer, and on the left we've got Evelyn with her mobile phone, and in the background Chris, who had his laptop. And they've been working on planning a holiday. Now they're coming together. They've been working individually. They've come together to share and discuss and plan because they're travelling together. So they're doing collaborative learning. In a moment, yes, Bob is going to put his finger on that picture of a hotel, and that caused a search, an associative search of all the objects on all three of their devices that were similar to that hotel. So we built a whole new search mechanism, an associative search, and it makes it a very nice way to find things and to collaborate. So Bob only made part of his file system available. He's now checking out something that wasn't available, but he's decided could be useful. He was happy with it, so now he's going to send it to the tabletop. Pomp, and then you'll see it appear. There it is. So now he can share that with everybody else. Now there's a map which they're going to throw up on the wall, because that'll be handy while they're discussing things, and then they can get on with their discussions using the tabletop for some of their collaboration and the wall at the same time. And their personal devices, which they carry with them, holding all their personal information and being readily accessible, just the way they want it. So here's another example of something different we've done. Again, a core idea. It's called Sydney Sidetracks, and it's based on some very beautiful content from the Australian Film Archives and the Australian Broadcasting Commission. And you'll see that it's got videos from the Film Archives. In a moment, they'll tap a red dot on the map. Pop, there it is. And in comes all the material associated with that area on the map. So it's this simple idea of interacting with things on the table. We've got very limited interaction. And this is a really nice way to move through a file system or a collection of information. Here's a human body explorer, which will come up in a moment. In this case, they've tapped a little dot on the body to get the lung, and you'll see some really ghoulish pictures, which hopefully they'll obscure. And again, same basic idea. You have hotspots, you tap them, and then you can see information associated with that hotspot. And here's another one where some people are looking at a whole lot of resources that are the Flickr feeds, and they're picking out some pictures that they want to use for some work they're doing. So they're just working collaboratively and clearly having a lot of fun. But again, exploring another medium and another way to access information at a tabletop. And then my favourite, actually, a collaborative maths game, which you might recognise. It's very good for teaching children to add small numbers and compare them with the number 21. And again, very, very simple interaction and wonderful opportunity to learn some maths. And our earliest work was motivated by making sure elderly people could use the system too. And that was wonderful for development, because it's quite challenging for older people to learn things. Okay, so when we have new interfaces like that, and lots of others like mobile phones, other devices you carry, tablets, portable computers, also your other computers, a whole personal digital ecosystem worth of devices, they create lots of possibilities, lots and lots of data about you. I call them digital footprints, and they have a huge potential for long-term modelling of me and my learning towards my Sisyphean tasks, perhaps. But all this data heaps and heaps of it of different colours and shapes, and we have a problem. And if you've read the little print, you might recognise this. Who recognises what this is? Put your right hand up, left hand if you don't. Thank you, everybody. Yes. Okay, so it looks a lot like a hat, but as the little prince in the book, or the little boy in the book points out, it's actually, when you interpret it properly, it's actually a boa constrictor that swallowed an elephant. And so it's often quite hard to interpret things. So here we have the data about me. We need to interpret it. And there's a whole lot of computer science that comes in there. And I'll be showing you some of that later. And what we want to do is turn that into some useful form, which is my learner or user model, a lump of information, a personal store of information that'll be useful for my long-term learning. And as Peter did mention, obviously, once it's personal information, there are all sorts of risks. Obviously, I can get some of it from places like Facebook and Twitter and all sorts of stuff like that. And I'm not going to talk about that today because no one else had papers on that, so I figured I'd save it. What I will talk about is what you can do with it if you manage to get it right. So how can we exploit these electronic traces, mirrors, to make mirrors and navigation tools? So this is work by Kalina Youssef, Peter Ryman, and Kim Upton, and it's very much based on the notion of a mirror. Now, Shakespeare said, "We know what we are, but know not what we may be." And I think he was being far too generous because most of us don't have a very good idea of who we are at all. How self-aware are most of us? Not very. So, let's take the case of learning to collaborate. That's a Sisyphean task. It takes a life to learn to collaborate. Sometimes you can collaborate well with some people, but you need to learn all sorts of strategies. That's something that the three of us were working on. Peter Ryman, Kalina Youssef and I. So now I have another question. First question though is put your right hand up if you've ever done anything in a group. Left hand if you haven't. I don't see a lot of left hands. Okay, in fact, none. So my next question is the one on this slide. Could you please put up your right hand if you've ever had a frustrating group experience, and left hand if you never have. I'm just looking. Is there a left hand? Wow, there's someone with a left hand up. I'm very impressed. Well, for anyone who didn't notice, there were a lot of right hands up. So there are a lot of problems in working in groups. And here are some of them. How do you get common ground? Social loafing, this brilliantly polite word for saying people who aren't doing their fair share. People tend to focus on action, especially the case I'm going to show you, computer science. Students rather disdain sitting back and reflecting and attending to psychological needs. It takes some learning to learn to appreciate they're important. Frustration with the quality of interaction. People who feel, I could have done it faster myself without having to build all that effort into collaborating. Learning group skills is hard. It's one of these Sisyphean tasks. And long-term collaboration does involve lots of complex skills. So this is a really important skill. And the work we did was in a capstone software engineering course. In computing, we always subject our students to a wonderful experience in their final semester, or maybe their final whole year, of writing a piece of software in a group, because that's how much of the industry operates. And we explicitly taught group work skills, something that's not often done. And we used a method called extreme programming, which has its own set of rules that are really about group work. Okay, we used a tool called TRAC, T-R-A-C. Let's have the show of hands. Put up your right hand if you've heard of TRAC, left hand if you haven't. Ah, the left hands have it. Okay, as I thought. So it's a piece of software for collaboration. It was used by the team members. Each team had their own TRAC site. But they also had facilitators or tutors, depending what you want to call them, the teachers for the course, people like me, and some of the clients also used this piece of software. So I'm going to give you a quick overview of it. Some of it I think will be very familiar. So firstly, there was a wiki. Put up your right hand if you're familiar with wikis. A left hand if not. Okay, so most people are good with wikis. It's got a wiki. It also has what's called a ticket manager. Put up your right hand if you're used to the idea of tickets. Not many. Okay, excellent. There's a mix. Okay, so the idea of a ticket is you make a ticket for each job that's to be done. Very simple. And in this case, you can see that the students have identified a milestone of the first demonstration, and in conjunction with that, they've got a bunch of tickets, a whole bunch of things that they've actually done because they're greyed out. And then they've also got their final report, and they've made a bunch of tickets. So each job that's got to be done, you make a ticket. It's really cool, and you can make lovely links between the tickets and the wiki and the next bit I'm going to show you, which is the version control system. So how many people are familiar with version control systems? Left hand if not. There are some people over here with no hands up. Okay, thank you. Okay, so version control is getting more common on wikis and stuff, but this is mainly for software development, and it's a version control system called SVN. That's really nice for managing software. There are a number of others. So this isn't a learning system, but we used in a learning context and we augmented it. But what was significant, and I'm sure many of you who've taught using any of the sorts of tools that support collaboration by groups, discussion boards or wikis, you get a huge amount of data. The students have got a whole semester working in teams of 7 with a client and so on, and they're putting lots and lots of stuff in there, and if you're the teacher, it's really hard to get your head around what on earth is going on there, and you'd like to make it accessible to everybody, because if there are 7 or 8 people using these facilities, how do they all know what's going on? Very, very difficult. So we started analysing the data and building some pictures. So this one is an interaction graph showing who interacted on the wiki. In other words, if 2 people edited the same wiki page, we said that was an interaction. And each dot is one person. So if you see this red dot at 3 o'clock, that's one student. We normally have their name on them, but we've anonymised that in this picture. And I'm going to show you a whole series of pictures, and each person would know which dot was them. And you can see this red dot's actually interacting with a lot of people. You may notice a striking feature of this, which is that whilst everybody is interacting, there is this green dot which is all on its own. Very sad. Now I have to tell you this person was officially the team leader. And you would expect a team leader would be coordinating the team by using the wiki, right? Well, I would. So this is a rather odd graph. And a graph like this is just wonderful to sit down when I'm a facilitator for a team and I say, oh, so what am I seeing here? It's very dumb data, right? It's just checking if people edited the same wiki page. It's not very rich, it's not very clever, but in this case it's very, very clear. Great start to a conversation. So here are some other ones. We did them for each medium. The top left is the wiki, the middle one is the version control system, the right is the tickets. And in the case of the tickets, the blue means that was the person who originated a ticket, so created a ticket and perhaps allocated it to someone else. So this red person you can see has got a lot of blue coming out of them, and they may well be the manager for the team. So they're allocating jobs to people, which is reasonable, if that's their role. But again, fantastic start to a conversation. The version control system is interesting. You can see really 2 pairs who are interacting with each other, and the others aren't. That might be fine. There might be 2 pairs of people working on the same code together. That might be their job. And on the other hand, it might not be fine. Again, it's the beginning of a conversation. This is another group, just to show you that they don't all look the same. It's much more symmetric, but some paths aren't there. We built some more activity mirrors. This is showing how much work people did. We called it the activity radar. So it's the same sort of idea. The red person at 3 o'clock is the same person again, but they move towards the middle as they do more work. And so you can see on the left, for the wiki, this red person is doing more than anybody else. And you can see on the version control system, the red person is doing more than anyone else. And you can see on the ticketing system, the red person is doing more than anyone else bar the yellow person. So you can very quickly see, well, the red person's pretty active. What does that mean? Well, you've got to start a conversation. Here's another group, just to show they look different. And here's a video over time, watching people come in and out. And when we made these available to students, they found them very illuminating. Because often you don't know how much you're doing relative to other people. And it's only using very simple measures, but at least it says something. Okay, then we went on beyond that, and we built a system called Narcissus, another Greek god. There's a theme here. He was very fond of looking at himself. So this is the track site, and over on this end we added a Narcissus plugin, or tab from the user's point of view. And this is what it looks like. So there's a header telling you who owns it, and you can choose the time period you want to see. We've got one overhead slide worth here. Each horizontal section is 1 day, and there are 5 users shown here. It's anonymised. So each block of 3 is for 1 user. There is a key in the upper right, but it's a bit hard to see from here. The wiki contributions are purple. The version control system contributions are blue, and the ticket contributions are green. And if we had other media, we could add another column. Now, if we click on a cell, it's very cool. It shows you what that corresponds to. So this was the version control system that the second person did on that particular day. And this is all the changes they made, numbered. And if I click on those, I can actually see them. Down here, we explain the scoring, and the person using it can control it completely. You can change the scoring. At the moment, it says that if you add 50 lines, you get 1 point, and it explains basically how you get things to be darker and how dark. And you can change it if that's what you want, because for some people doing some things, it might be important to have just a fairly small resolution, and for other people, you might want something else. Each person can see their individual summary, and the coloured bit is what they did, and the grey is the group average. So if you do above average, you sort of have a glow of your colour sticking out, and if you have below average, you have grey sticking out. Here's another group, and we just click on the ticket for the day. We see all the details, and if we then click on that, we can go right down to the ticket. And so with just a few clicks, you can use this visualization of group activity to explore a whole information space. And it's all the details of that ticket. So that was really nice. It worked beautifully. And when we started using these sorts of things in our group projects, we stopped having the really pathological groups. We discovered pathologies early on and were able to help them. But we did data mining, educational data mining, on the data from this track site. And now I want to speak very briefly about some of that. So this is a whole lot of people: Kalina Yasef, Agat Mersrong, Irena Koprinska, Dylan Pereira, and Osma Zayin. And here is a summary of 7 groups, and they're in rank order. Group 1 was very good. And you might be able to see some of the reasons that Group 1 was a very successful group. They have one person who, when we did the mining of the analysis of all the interactions, one person had the behaviour of a manager, and that was the person who was the manager. That's what the star means. The other good thing they had is 3 people were writing code. Looked like developers. They had a developer profile, which for a software engineering project is a good thing. Let's see some pathological groups. Here's one that was quite dysfunctional. And look at them. No manager, 0 people looking like their managers. But they actually had a problem. You can see the 2 stars down in the other means that they had 2 managers. They were a really pathological group. We had a manager, they had to be fired, and so there was someone else. And as you can see, there's only one person who looks as though they're writing code. Group 5 is dysfunctional in another way. 3 people looking like leaders and the leaders writing the code. There are many more ways to be dysfunctional. Now, we've been doing quite a lot of stuff with this data mining and trying to turn it into something that we can explain to people, and that's still work in progress. So now I want to move to something completely different. It's tackling the problem that a university like this has of designing a whole curriculum for a university degree, 3 to 5 years of study. And what we want to do is to make sure that we're in control of our curriculum, so that when I'm a lecturer and I take over a course, that I understand why the curriculum is the way it is. So for example, I might be given the 3rd programming course, and I've been told that there's students who are meant to write an essay. And I say to myself, well, I'm a computer scientist. This is a programming course. Why are they having to write an essay? And the reason they might have to write an essay is it's a compulsory unit for computing students, and it was decided that to build the skills in written communication, that was where we would have to have a written essay. And there are all sorts of things in designing a curriculum that are planned out and designed that have to be kept for the institution. Designing a curriculum for a place like this is really hard because we try to give our students flexibility. So Richard Gluger, Tim Lever and Ray Lister and I have been working on that. We've got a system called CUSP, and at the moment we have over 200 degrees and 2,000 subjects in it, and at the moment it's been deployed in the Faculty of Engineering and IT, in Architecture, Health Sciences, Commerce, and there are others clamouring at the door, as well as some other universities that are interested, because our government's really interested in quality management, and this is really quite central to it. It's no coincidence that the people who were early adopters are all people who have to go through accreditation. And now I'll show you the motivation for it. So here we have university degrees and curriculum goals. So here's the University A. Probably all of you are at University A. And it has graduate attributes. So someone writes a list of things that we would like all our graduates to have by the time they finish their degrees, which in the case of University of Sydney is that they are good communicators, they've got a good sense of ethics, and they're good at managing themselves, and they've got a spirit of inquiry and all those sorts of things. Each faculty refines them in terms that meet their own faculty requirements. So the health sciences people would have stuff about relating to patients, and engineering has stuff that's kind of engineering-y. I hope you don't blink in this because it's going to get really complicated. So here's another faculty, Faculty Y, which has got its own slightly different one. And we give a degree out of the Faculty of X and a degree out of the Faculty of Y. And we have combined degrees in this university, which makes it even more interesting because those students have to get a tick from both faculties. And then we have a whole lot of subjects that fit into possibly any of these degrees, and we've got to make sure that these subjects ensure that our students get these skills and that there's progression over the 3 to 5 years of their studies. So there we are. Ta-da! We design our curriculum and we're able to tell people, yes, we did this because of this university graduate attribute, and we're building our graduate attributes. Okay, now Discipline X also has an accreditation body. If you're really lucky, you might have 2 or 3 accreditation bodies. In computing, we have IEEE software engineering people and the Australian Computer Society. And they have their own standards. And with due respect, they don't actually care to look at the university standards. They just specify their own, and we've got to demonstrate that our students have them. So somehow we've got to map them to the degree. And here's another professional body and another one. And let's do another discipline. And then we've got a whole lot of stakeholders who've all got to fit into this. Subject lecturer, degree coordinator, faculty admin people, an enrolled student who has to work out why they're doing what they do, and maybe a lifelong learner who wants to take the odd subject. And then we've got all the standards people. And how do we make all that work? Well, I'm actually delighted we have all this, because the fact we've got to keep these accreditation people happy means that my colleagues are all inspired to do a really nice job of defining their curriculum and mapping it. So we built this system where the faculty offers a degree with subjects, and we define within our software learning outcomes and teaching methods. And then we map the learning outcomes to assessment tasks, and we write all this down. Now, the faculty defines its primary skill set, which has a set of skills, and we have a set of levels because we want progression. And then we have a secondary skill set, which comes, say, from some other source, and we map them across. Now, we then do this mapping from learning outcomes up to the university's own attributes. That might sound pretty abstract. Whoops. But let's see what happens. For a subject such as algorithms and complexity, a wonderful choice, the lecturer specifies exactly what they're going to teach. They indicate whether the students have practiced it and whether they are assessed. And eventually, someone can centrally map this into various levels for each of the graduate attributes. So what you can see in this particular diagram is a whole degree and how we develop design and problem-solving skills. And you can see there's stuff at level 1, then level 2, then level 3, and so on. And the core is at the very top, and then there are some recommended and optional subjects. And then we have some summary pictures. Now, I have to say, some people, when I tell them about this, say, don't let our university admin hear about this. But if you actually really want to be on top of your curriculum and curriculum design, and enable a lecturer who comes in and wants to do their job properly to be able to understand what they're doing and how it fits in, this is pretty exciting stuff. Now, we've taken it one step further, and we've taken it to the fine-grained level as well in the case of computing. So we've taken the strawman curriculum for computer science, the Computer Science 2013 curriculum, and we've built a system that enables you to map a whole degree against that. And because we know computing educators need to indicate progression, we've built tutorial systems for your average academic to learn Bloom taxonomy or neo-Piagetian coding. And the response is just wonderful. At least at computer science education conferences, the response is wonderful, and we're just expecting people to beat their way to our door. Okay, so that was building tools that will enable us to say something about what our students learn over many years in a degree on skills like communication and group work that I've already talked about. So now let's go back and pull all these threads together. Some novel user interfaces, educational data mining, learner model visualization interfaces, and then throw in classroom orchestration. And this is work that Roberto Martinez and Kalina Youssef, and Roberto speaking this afternoon in a session. So here we have something I don't need to sell to you, that collaborative learning has much merit. And tabletops seem to have a really special potential role in supporting collaborative learning. So tabletops in classrooms. It's a field in its infancy. The hardware is developing month to month. People kind of think it's cool, but they don't know what to do with it. But the reality is that if a teacher's going to use these sort of tables in the long term, when they get very cheap, they're going to have lots of groups. And students need feedback. At the moment, we have lots of times when students work in groups and teachers can't tell what's happening in the groups. The tabletops could change that. So we can give new forms of learning support because we can capture the traces of interaction. So the thing that Roberto has built is a collaborative concept mapping task. Okay, let's do the hands because you've been sitting passively for far too long. Who's familiar with concept mapping? Right hand up, left hand if not. Oh wow, nearly everybody I think. Okay, so I don't have to sell it to you. Joe Novak made it up as a very cool way to externalise your understanding and also to improve your understanding, your thinking about your understanding. So it's used in lots of domains and it's valuable for promoting meaningful learning. So the way it works in our system is the students use CMAP tools, a standard piece of software for a desktop, to draw their own private maps in the peace and quiet of their own home. So for example, we've recently done work taking the national guidelines for nutrition, because our nutrition unit was curious to know what people understood that to mean. And people have been asked to draw their individual concept maps. And then they come together and create a joint map. They work out what they understand together. And so now I'm going to show you some video of some people who are doing that. The big map you can see as a blob in the front is the personal map, and now they're deciding how to create their joint map amongst the three of them. And so it may be they're things that they can't agree on. If we were doing the classic example of coding something about nutrition, I might believe all fats are terribly healthy. That's what I read in the brochure, and you read something else. In which case we might show that I will put one proposition in, showing my understanding, and you'll put something else. You can't see it very well in this, but everything is colour-coded. The person on the right is the blue person, and so everything they do looks blue on the map, so they can see that. So they could put a proposition onto the concept map that is theirs, and then so the group could agree to disagree. On the other hand, we would hope that they would discuss things if they disagree. So if you've got some students doing this in your classroom, how do you work out what's going on? And we have this wonderful display of what's going on. So here's a case where we happen to have three groups. So this is data for one group, and you can see it's duplicated for the other two. Now, the first of these has got a heap of machine learning that Roberto spent lots of time doing, your classic stuff where we got people to code interaction, and then we threw machine learning algorithms at it. So there's a lot of stuff there. I will show you more detail, I'll talk more about it, but for the moment it's a whole lot of stuff. All the data we've got, we try to get some fancy algorithms to learn enough so they can make the arrow go to the right if the group is being very collaborative, and left if they're not. And then we show the interaction. So if we're doing concept mapping together and I touch objects that you put on the table, that shows a level of collaboration, shows something about what's going on in the group. And again, in a real classroom, the teacher would have some sense of what the students are like. And then we have pictures showing the level of symmetry. And the red is the, well, it looks more pink anyway. The reddish one is showing touching at the table, and the blue is verbal participation. In other words, people talking. And again, it's very like the stuff I showed you before in conjunction with track. These ones are quite simple measures, but they turn out to be pretty effective. Here's another one, which is showing the evolution of the map. So the students are working on some concept mapping task, and you can see it grow. And you can see on this one on the left, it's probably quite hard to see. There are only, the red student hasn't done very much. And there's probably a bit clearer in the bottom, though the colours may not be very bright for you. And over here we can see on the right-hand one that the students worked independently. But at a glance, teachers can see a lot of what's happening and perhaps decide which group to put their time into. And perhaps more important, they don't just get the final result as you normally do in group work, they get quite a lot of data about what was going on. And what's more, this is a great way to start a conversation with the groups and to build up some metacognition. This is a bit about how it works. So there is a Connect that's looking down at the table, and you're seeing on the very left what the Connect sees, and on the right we're showing you some indication of what we've got. A very fancy microphone that's directional, but it also can separate speakers out so we can tell who's speaking. Now, right at the moment, some of that technology, well, the Connect is pretty cheap, but all of that stuff is going to be very cheap and very plausible in the long term. So, what comes next? If you're going to have these things in your classroom, you're going to want to be able to control them. So the next thing is the potential to do some orchestration of the classroom. So here's a class. If you look very carefully, all the students are actually Roberto. With a masterpiece of Photoshop. And this one is a real classroom, but the people are blurred out. And the teacher has a way of controlling what's going on in the classroom. in the time available, I'm not going to go into that in a lot of detail, but the teacher is invited to do an orchestration phase to plan what's going to happen in their class, and then they can control the tables, and then at the end they can look at the data to see whether they did what they intended to do. So you can see here there's a start all to start all the tables, and that's nice because you can. All right, so next phase says move to the next stage of the class activity. Block all says stop everything so that they'll listen to me. Well, maybe they won't listen to me, but at least they won't be playing with the table. You see, I could do that with everybody's laptop. Stop all the mail. No. Unblock all. And sending a message, such as here, 2 minutes to finish, a reminder to everyone. So a bunch of stuff that lets you see also on the right what's going on amongst the group at each table. Again, a very quick visualisation. So, my summary. I tried to introduce Sisyphean tasks, and lifelong learning, a lot of the work that our group does is very much at the systems level, collecting data, but I've spared you that. I've just tried to paint the big picture. We've introduced some of the novel interfaces we're building because we think they're really important, and we have to build them for learning. The whole role of electronic footprints and how we can exploit them, long-term curriculum, and I now want to acknowledge a whole bunch of people who've done different things, and the people who've been sponsoring the work. And now, questions. Thank you.
Thank you very much, Judy. I was impressed by your subtle way of lecture room orchestration. If you try to do your email and you have to lift your hand all the time, that really gets in the way, doesn't it? Yeah, questions please. And we hand around, I think we have an improved microphone, or so we are told, and we hand around that to those who have questions. Or
great talk. Thank you so much. So in one of the, towards the end of your talk, you had the slide where you showed your collaboration meters, and you showed a couple of the predictors that you used. But I guess what I'd like to know is, you said also a little bit about what you consider good collaboration, because you said if people are disagreeing, you're hoping that they're discussing. But I guess what I'm not sure is, what's the connection between that idea and what you were really assessing? So can you say more about what those meters are actually measuring, and what you've learned about measuring collaboration around tabletops?
Okay. So Roberto's now done a whole lot of studies around tabletops, several, in which he's done the arduous job of coding video to code over small periods the level of collaboration, and then we've taken whatever data we've got and thrown machine learning algorithms at it. And usually the data is the touch. Whether people are touching, who's touching. I guess I forgot to mention that one of the things Roberto had to do that was quite novel and we think works really nicely is that, with the exception of Diamond Touch, hardware technology generally that's got multi-touch can't distinguish one user from another. And so the Connect does that. So we can tell who's touching with some error, but we've now measured that and it's pretty low. We've got the directional microphone, so it's measuring who's talking. We theoretically, if we had your technology, could analyse what they're saying, but we don't. There is a question on privacy. Our ethics forms wouldn't allow us to do that with what we've done, but obviously in the long term one could. And then for this particular task, the concept mapping, we have some progress towards the task. And we've now run it several times in somewhat different ways. But for example, if the teacher has given an expert map, and maybe the teacher's provided propositions that are problematic, that they regularly see students have problems with, the classic, I guess, a whale as a fish versus a whale as a mammal, maybe they've purposely put that there. So if we've got that data, we can put that into the analysis as well. So we can see who's contributing propositions. We can also compare the propositions across the group map and the individual map. So we could see that if you and I were working together and I was being a bully and all the things that were turning up in the joint map were from my map and none were from yours, then that's probably saying something. So depending on exactly what we've got and how we configure it, we can steal all the data we've got and try and turn it into an absolute measure. The downside of that single measure is it's now just one measure, but it's very good for a teacher who just wants 3 things to look at before they drill down and look at more detail. So if that answers the question. And obviously the sky's the limit there. We could probably go a lot further. And again, if you actually had richer data, you could start turning it into something that the teacher could discuss with the student. So they could, I mean, the scenario I gave where I'm bullying you, the teacher could come along and say, well, you know, how is it that none of your things are turning up? Gee, this looks quite good. And you know, I see it very important to use this stuff as a beginning of a conversation. It's not smart enough to treat this as a way of grading anything, but it certainly tells you a lot more than you get at the moment. Because normally when you have students go off and work in a group, you see the final product and that's it. And there's lots of literature, but certainly the stuff Roberto's done, the final product doesn't correlate with the level of collaboration, because the final product, well, as we all know, kids doing a learning task, often one student could do a very good job entirely on their own in terms of measuring the quality of the final product, but in terms of measuring the learning and the collaboration and everybody doing the things you had intended, you may not be getting that. So you're getting a lot of insights that you never had before, and an opportunity to start asking some questions so you can tease it out and talk about what's going on.
There was a hand over there, I think. Along there. So, question?
So thank you very much. And it's very much close to the previous question. So I would like to ask you, what exactly do you measure in collaboration? Do you measure the discussions between the students? What do you think the collaboration is?
Okay, I think that's a very fair question, and I guess there are 2 sets of answers. One is in terms of track, which is very simple. We measure very simple measures. We measure lines of code each person puts into the version control system, lines they put into the wiki, and tickets they make, tickets they allocate. There are a lot of actions you can do on tickets. So we measure, we just count very simple things and tote them up. And we basically use that as a starting point for you to explore. So it's a very, very simple use of the data. In the work on the tabletop, it's a lot more sophisticated, and it's based on someone having coded things in the past that enables us to run machine learning algorithm, or to build a model which will interpret the data and give us some sort of indication. Now, in a gross level, it seems to work pretty well, but subtle it isn't. There's a long, long way to go to get to the point where you could say, I mean, let's just take a concrete example. We've got 4 people working together, and we've got a very taciturn person over here who doesn't say anything. They're just sitting and watching. I think there was the monitoring student of yesterday. But they're actually watching, and then they come up with the solution to the problem at the end. Obviously, on our data, they're going to look as though they're not doing anything, because they're not talking and they're not touching the table. That's fine. So in the case of the concept mapping, you'll be able to see they put in the key concepts at the end, so you get some data. But even so, at this stage, all it gives you is a starting point for talking to the kids and saying, well, how come this guy hasn't talked? Now, again, if you're in a classroom and you know the students, you might have an understanding of that student and what's going on. Equally, if it's a student that's been bullied and not allowed to talk, I mean, we just did a study at the Australian Museum, and I would have liked to show it, but I had too much already, where we had kids go out with iPads to do their worksheets in the various exhibits, and then to come back to the table, and each iPad group, which was usually 1 or 2 students, would put it on the table, talk about it, and then they made a collaborative poster. And we had some students using the table and some using a whiteboard. Now, you know, some groups collaborated better than others. Some very, very simple data tells you a lot about what's going on in these cases and a lot of the pathologies. So it's not as insightful as a teacher sitting there watching a video the whole time. But if you're a teacher with 4 or 5 groups in your classroom, it gives you a quick view of something that might help you work out what's going on. And the orchestration tool could also help you monitor your own time spent with each group, which would be very cool, because you might aspire to spend equal time with each student, and we know that teachers don't tend to give equal time to each student. So just imagine being able to monitor that, or even the time you spend with each group. So I don't know if I've answered your question satisfactorily. I guess the real answer is it's a very simple measure. And because we use machine learning algorithms that built some model, we don't actually really understand it at all. It's very inscrutable. After the introduction I got from Peter about liking things that are scrutable, that the system can explain everything it does, this can't. It just says I've got this very crude measure, but I've got this other bunch of measures that might help you. And we evaluated it in taking data, old data, and giving it to some teachers and asking them what they thought it meant. And they were able to make quite good interpretations that were very close to what the video said. So maybe that reassures you a little. I guess the reality is it seems to be useful, but it's just our first step above nothing.
Time for one more question. All the way. Keep your hand up, that would help.
I wanted to ask you about the intersection between the researcher, the teacher, and the ethics issues that you're facing here. Because you've mentioned something about the ethics one. I noticed also in describing the interaction of a group, you've used the term bully. Now, I'm just wondering, what ways are you going about addressing some of these sorts of things that are going to come up in the future in terms of applying these technologies in that interface between researcher and teacher and how the information's used?
Okay, it's a really good question if I understood it correctly, but tell me if I got it wrong. Okay, so at the moment we're doing research, and when it comes to ethics, we tell the ethics committee what we say we're going to do, and then if they approve us, we're allowed to do what we said we were going to do. And so when I was saying we said explicitly in the form we weren't going to analyse the speech, that means we can't. I imagine that if we'd said we were going to analyse the speech and we put on the form for the people to sign that we were going to analyse the speech, that would have been fine. So I don't really see that as a problem. It's just that we have finite resources, and it just seemed much simpler not to do what we weren't, you know, we didn't really have the resources to do that anyway, so it seemed a good place to stop. As for if you get into a real classroom, I actually see some real challenges. I think, for example, of the track site. We use it in a course where I hope that I build up a relationship with the students, that they understand that I don't use that for assessment at all. I tell them I don't use it for assessment at all, and in fact it's almost true. The only sense in which it's not true is that if there's a student who would fail, because the rule is that they'll only pass based on what they write in their report, but if there's someone whose report doesn't quite cut it, I will use this to go and hunt out stuff that might just tip them to a pass, but I don't advertise that except on this. So I think that the calibre of these tools is such that you have to say you can't use them for assessment. Now there is the issue that you could be caught doing things that you'd be very embarrassed about. And I do think that is an issue with the technology we have today. That when you forget it's there and you relax, you can do all sorts of things that you're not happy with. And that's going to have to be something that will have to be dealt with. I can imagine a teacher perhaps wanting to use this sort of technology sometimes in order to find out what's going on in their classroom, maybe with a new class to get a sense of what's going on in the groups. Maybe not every time. Maybe sometimes to monitor their own activity. We're also doing stuff on people monitoring their posture and their activity and so on. I actually think it's a bit bizarre to do that all your life. I can imagine you do it for a period of time. So I think we've got to find out where that's going to be, but you're right, all the data we're keeping could well be stuff that might come back and bite us. Is that what you meant?
Well, the other one that you haven't addressed, the other one that you haven't mentioned about is when you've got students in your groups, in university classes, do they have the chance of not participating, choosing not to? I mean, having a background in the psychology department where we deal with this in terms of their participation in research experiences, I'm just wondering how you're dealing with it in those courses where part of the course is to participate in these types of experiences.
Well, as I said, we have these university graduate attributes that came up in one part of the talk, and one of them is collaboration. As it happens in software engineering, computer science, one of the things we want students to do is work in a team, and we use, as it happens in our case, a method called extreme programming where there are different roles. Each person does have to play an active role, and the students are told that if they want to pass, they've got to collaborate. They don't have a choice. That is what that unit is about. If you enrol in that unit, you've signed up for collaboration. You can't say, I'm sorry, just not an option. You have to choose some degree that doesn't require that subject, which is possible, but it won't get you an accreditation because that unit is compulsory on all the accreditation lines.
Which brings us back to the initial slides on privacy. And I should have mentioned, Judy, that all of this is recorded. Join me again. And I know you don't drink wine, but I'm sure you'll have guests.
Thank you. That would be wonderful.